everybody, Harold here. My third and final imputing missing values video, and today we're going to do it with mice. Mice is what I would call advanced, uh, probably used by a lot of statisticians, and it's a great package. So let's get started. Here we are in our studio. So mice is multivariate imputation by chained equations. I know that's a mouthful. What it is a package that lets you impute based on many different statistical methods, and if you don't tell it what to, it will pick for itself. And there's some good visualization in here also. So let's get started. Load tidyverse, library tidyverse, put Vim in there, mice, zoo, in case we need them, specdf, bizdat, skimmer, and the stats package. A great resource on this. I got a lot of my information out here was Jerko Vink's vignette on mice. Here's a link to it. I'll put that in my description. I'm going to use the diabetes database. It's included in the Vim package. So I'll show you that. It's got pregnancies, glucose, blood pressure, etc., etc., age, and then outcome, and they predicted whether or not this person would have diabetes, and yes or no. I don't want to do that yet. I'm going to clean it with janitor. I need the janitor package. So we'll say library janitor. Also, now I want to clean names with the janitor package. What that does, and then I'm going to shorten some of the names too. This will just make it easier to read when we plot stuff and easier to remember the names. So let's glimpse that. It's got our change shortened names. We have 1, 2, 3, 4, 5, 6 integers, 1 factor, and 2 doubles. Let's get a summary. Here's our mean, medians, and quartiles for each column along with the NAs. So we have quite a bit of missing. Some of these columns have a lot. Probably not good candidates. Let's inspect the correlations. So what I'm doing this for is to kind of find the one that's best for a model, and we're going to look at for a low p-value and a high correlation. And it's BMI skin thickness. So we'll concentrate our analysis on that. So let's look at that with the aggro from the Vim package. Diabetes numbers equals true. So skin thickness in general, probably not a good candidate. It's got a lot of missing values, 30% above our 5% threshold. There's probably a reason for that, and we should go look for it. But we're not going to do that today. We're just going to notice that there's a lot of missing with skin thickness. And here's the combinations. We'll do an MD pattern. I believe that's skin thickness and insulin here. Skin thickness combinations down here. 336 had combinations all over there. 119 were missing insulin. 170 were missing insulin and skin thickness. That's how you read this. So this gives you an idea of the patterns of missing this. When inspect now, skin thickness 29.6%. Probably in real world, not a good candidate, but we're going to impute that one today with mice. So I'm going to get the means of every numeric column. So I could say diabetes, pipe that in and select where is numeric, and then summarize them across everything. So here's our original means for pregnancy, glucose, BP, skin thickness, insulin, BMI, pedigree, F, and age. Skin thickness 29.15, BMI 32.45. So I'm going to fit a linear model. This looks a little different, but you can fit one this way with a width, and you have to do it in this case with the mice package when you do the imp. So fit one, model one, with diabetes, a linear model with BMI as the dependent variable and skin thickness as the independent variable. Let's see a summary of that model. So right away, see that the very high estimate, very low p-value, high F statistic. This is a good candidate. 42% of it can be explained, even with the variables still 41 point. Adjusted for other factors, 41.9% of BMI can be explained by skin thickness, the low p-value, the high F statistic. This looks like a good relationship here. So we know that. We're going to go ahead and run a simple imputation. And with mice, you can use all these different methods. So same methods, mice, impute 21 bin, lasso, norm, norm predict, PMM, pan impute, mean, whatever. All these different S3 methods. So we're going to start with a simple one, and we're going to impute. We're going to call an object imp. We're going to impute mice. We're going to use the mice imputation method on diabetes. We're going to set the method equal to mean. M equals one data set, and max iterations is one time. It's going to really simply do it. You could set your M's to whatever you want. You could run them 25 data sets 40 times. You get a lot of imputed data back. But the more you run, it might get better. There is a curve on that. So careful. So let's show the methods used and what they call the predictor matrix. So it used mean because I told it to. Uh, just for a second here, let's take that out and I'll show you what happens. So if I run it again without the method, it used predictive mean matching instead of mean. So it decides for you. I'm going to put mean back in based on what it thinks, unless you tell it. So I can say method equals mean. Run it again. I need to put another comma in there. Okay, so method is mean, and this is kind of cool. Your predictor matrix. I won't show you today. It's a little complicated. But what this is what's used to predict what, and you can actually edit this. And if you don't want pregnancy to have any implication on your BMI calculation, you could take it out, and so on and so forth. And if you want to see the results, imp obviously doesn't give you the results, it just gives you a class number of imputation methods in the predictor matrix. You want to see the results, you say complete imp, and you'll see the imputed values all throughout here. Now we're going to run the fitted model on imp. So with imp, linear model BMI skin thickness. So let's compare the summaries on those. Uh, our first fit one down here, p-value negative e to the negative 2 to e to the negative 16th, 389 for the F. Well, it's got even better, negative 5.89 so it's way better. The p-value was way lower. It looks like the intercept and the skin thickness stayed about the same. So it looks like we're still doing good with our imp after we did the regression. And you can use some other methods. Let's run one called norm.predict, and that's just predicting normal regression Bayesian method. And we can see what methods it did. So norm.predict, and here's our predictor matrix, our complete imp. And I'm not going to do a norm.nuff. So you get the idea. You can choose your method or let it choose the method. Let's see that one. You can see the attributes. So these are all attributes. If you type imp $, you can see what they are. It's a class mids. If you type imp data, for instance, that's your original data with all the NAs in it. If you type imp, it's going to show you the imputations in your data. For instance, let's go back up here. There's a lot in that one. Yeah, it's insulin. 1, 2, 3, 6, 8. So it skipped the ones, but it shows you the ones that imputed. So there's a lot in some of these. Here's a small one. Glucose, there was only 1, 2, 3, 4, 5. It imputed all those, and that's them. The one is the first iteration. So if you want to show all the iterations, you could do something like create an object, lead imp3, and then show it broad. So this is all pregnancy iteration 1 for each variable. We only did it one time. Or you could show it long, complete imp long. Same thing, long format. Uh, the other cool thing you can do is when I set iterations to 1 and m to 1, you could change that. I'm going to make it 3. So imp mice diabetes m equals 3, print equals false. I'm going to set a seed so we can reproduce the results. So I'm going to plot that with 3. What this does is, let me zoom in on this graph. The object, so these are your 3 runs and their mean and standard deviation. What you're looking for ideally is convergence. So on BMI here at the bottom, this convergence. Look, that's what you're looking for. That'd be one we would pick. So when you plot these, you see the convergence. Pretty cool. The other thing you can see, I'll blow this one up, is a strip plot, and it shows you where it stuck the new values in on each iteration. So there's your original data, and the light reds in here are your imputed data on each iteration, 1, 2, and 3. They're all well within range. Looks pretty good. We got one low guy here, but here. I'd probably pick this one, but you know, that's pretty cool too. So, okay, that's mice. And that's really just touching on mice. If you're more interested, please go into this vignette, check it out. I hope these helped you with your imputing, and I hope you like them. If you did, please like and subscribe, and I'll see you next time. Thanks, everybody.